Okay, this is the motor circuit which will be connected to pickaxe. This is the circuit after the pickaxe, and the pickaxe will be receiving signals from the phototransistor circuit. And here we are going to demonstrate how the feedback system is working in our light controlled automatic umbrella. And as you can see, this part is the H-bridge. H-bridge is needed to enable two directions of rotation. This
It's our best one.
is connected to the motor, and motor will be rotating counterclockwise and clockwise in our demonstration. And this is the pickaxe, which will be outputting 4 signals respectively to these 4 resistors, which is part of the H-bridge system. H-bridge system contains the 4 resistors and the 4 Zener diodes and the 4 PNP BJT junction transistors. And Marcus?
Alright, guys, so what we have here is an incoming voltage going into the pickaxe, which is simulating the photodiode circuit. And so anything from 0 to 2 volts is a value that indicates that there's not enough lighting. So the motor's going to turn to open up the umbrella to allow more light to come in. Now between 2 volts and 3.6 volts is a comfort zone where the umbrella will stop, where there's just the right amount of sunshine there and the umbrella just stays at the same place. Anything above 3.6 volts, the motor turns the other way to close because it's too hot outside or too much sun intensity, so the umbrella closes to to balance it out, to bring it back down. So I'm going to lower it down to anything below, starting at 0 volts or 100 millivolts. I'm going to increase it. The sun's shining pretty brightly. Bam, 2 volts, the motor stopped. I don't know, you gotta, motor has stopped, and I'm going to increase it here. Come back. I'm going to increase it here. 3.1, 3.2, 4, 6. 3.6, the motor turns the other way. I bring it back down, it's still turning. The light intensity is going, it's decreasing, but it's still turning in the opposite direction to shade us, to close the umbrella. So it reaches about 1.8. Stops, and it reads the 80 again. If it increases, it won't increase to 3.6 again. Decreases. If it decreases less than 0.8, it's anything between 0 and 200 millivolts, it starts turning the other way to allow more light to come in. So that's how our feedback system is working. It's this incoming voltage is simulating from the photodiode circuit. It's getting converted into 80D conversion through the pickaxe, which goes to the H-bridge and turns the motor both clockwise and counterclockwise to compensate different varying amounts of lighting.
Okay, so we have 4 critical values in our system. This is called hysteresis. And even so, let's say we are at 1.4. Currently, it's not moving, but when you go back down, it'll keep running at 1.4 volts. So the hysteresis system is kind of having a memory in the system. So it starts where the system is, where you are at the in which loop in the system you are. And then can we demonstrate like having the 2 layers of protection again. I didn't get it. Okay. So currently, it's 1.6.
Yep.
And it's going clockwise. And it stopped.
2 volts stops is at the comfort level, and then when it goes over 3.6, which is another critical point, it should go counterclockwise to close the umbrella. So here, let me increase it to 3.6, and as you can see, the motor is going counterclockwise now to close the umbrella. And as the umbrella closes, as the motor turns to close the umbrella, the intensity is going to come down. The intensity is going to come down. It gets 1.8, it's going to stop. Now it's going to read the ADD again. The sun's always changing, so if it goes, let's say it still decreases at 0.9, as you can see, the motor is turning back counterclockwise to let more shade in. As that shade comes in, turn clockwise to allow light to come in. As that light comes in, this number is going to be increasing. Bam, 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 bam. It's going to get to 2 volts. I missed the one. It's going to get to 2 volts, and it's going to stay in its comfort zone. It's going to range here, 2 volts. In between these values, it's going to stay in the comfort zone.
So another reason we had this not 2 but 4 critical values was that it would prevent the umbrella system to flip backwards and forwards, like transiently. And so this was our demonstration, and lastly, I'm gonna show you the umbrella model. It's like this. Okay, and this is Marcus.
This is Marcus drinking a Diet Mountain Dew because it is 4 o'clock in the morning, and actually I shouldn't even be drinking Diet Mountain Dew, but I am.
Okay, I think we should stop this video. Wait, I want to.
This is a video or a picture?
Video.
Oh, it's a video.